Good afternoon and welcome to another session on engineering graphics. I'm engineer Yash Chawla from Parul Institute of Engineering and Technology, lecturer in mechanical department. Today, last time we discussed a little bit on introduction of engineering graphics, what all instruments do we use and what are the different types of lines and all other kind of things that are there. Today we are going to discuss a specific topic, that is loci of points. So let's move on. What are we going to discuss in today's session? In today's session we are going to discuss what is a locus. In last session we discussed in very brief that what is a locus. Today we are going to elaborate it. We are going to solve examples that are there in our syllabus, and we are going to discuss some common loci that we encounter, and moreover the simple mechanisms that are there: simple slider crank mechanism, offset slider crank mechanism, 4-bar chain mechanism or link mechanism, and oscillating pendulum with a rotating disc. These 4 examples will be solved here today. So let's start. Loci of points. What is a locus? As we discussed in last lecture, that basically if I give you a set of points and you connect them with a line, or say with a segment, then that particular segment, a closed curve or any kind of segment, is known as a locus of that particular point that the points have come up and created together. So here is a very nice example. This is a normal picture which has been taken by a very low speed camera, and we can see that there are cars that are rushing on both the sides of the lane, and one side the cars are coming towards us and the other side the cars are moving away from us. So we can see that there are 2 lines, there are 3 lines on both the sides. On left hand side there is yellow lines, and on the right hand side there is red line. What do you think, how have these lines have been created? Now each and every car has a headlight and a tail light. Headlight is yellow and tail light is red. So when lots of cars are moving at high speed, what happens, that those dots, 2 dots, those are the headlights, get connected when they are moving, so it becomes a straight line. As you can see here, this is the moving headlights that form a straight line, and these are the tail lights that form a straight line, both one and the same thing. So there are 2 conditions. The points are following a particular path, and on the other hand they are following the road, so we get these particular lines. So basically this is the idea of locus. This example was discussed last time also. This is a cow grazing in a field, but somebody has tied it to a pole, and that string is of 5 meter distance, or say a 5 meter length. Now we want to plot the locus, that what is the maximum distance that a cow can go. So we will think of something like this. The necessary condition is that it should follow a particular path, and the given specification is that its distance should always be 5 meters from the pole, because the thread or the rope that has been tied will not allow it to go further than that. So then what will be the locus? This will be the locus. It will be a circle of 5 meter radius. Now this was an example to understand what was locus. So now let us discuss some basic locus that we encounter in our day-to-day life. Now we have a point P. I want to draw a locus of point which is d distance from this particular point P. So what will be its locus? So we know that if a same point moves from a single point, then a circle is created. So this dotted line has distance equal to d from P. So all the points on the circle come together and form a locus of point on the circles. Another example, the locus of a fixed distance t from a line L and has a parallel line. This is a line L. So I want to draw the locus of points which are at a d distance from this particular line. So distance can be above the line and it can be below the line. So first I'll take above the line. So this is at a distance d. So a line parallel to this particular line L will be the locus which is above line L. For below, again the same thing, it is at a distance d, so this is the particular parallel line that is the locus. So the two dotted red lines show the locus of points which are at distance d from L. Moving on, the next is the locus of points equidistant from 2 points P and Q. Let's see, this is a line segment, 2 points P and Q. I want to draw the locus of points, or I want to draw the points, plot the points which are equidistant from P. So first point would be the midpoint of this line. So if I imagine points going upwards and downwards from that midpoint, then I'll have a perpendicular line to this line segment PQ. You can see all points on this particular dotted line, that is red line, are equidistant from P as well as from Q. Now we have two lines, L1 and L2, and we want to plot the locus of points which are equidistant from both L1 and L2. Let's see the line first. This is L1 and L2. So where do you think the locus of points equidistant from L1 and L2 lie? Say we have a distance d from above and below. So a line that is parallel to both the lines and passing through the center would be the locus of points equidistant from L1 and L2. Now again we have two intersecting lines, L1 and L2. Let's see, this is L1 and this is L2. Now I want to plot locus of points which are again equidistant from both the lines. Do you get it? These are both bisecting the angles and we have the locus in red. Now let's get down to a slider and a crank mechanism. Now what basically is a slider and a crank mechanism? As you can see on the right hand side, the red disc is rotating, and on the other far right hand side there is a yellow block which is oscillating from one point to another point in guides that are in blue. And red disc is connected, red disc and yellow block is connected through a shaft, that is the brown bar that you can see, which are hinged so that they both can move. Now what basically is happening is either the red circle is rotating and due to that the oscillation motion of the yellow block is being caused, or we can say the other way around, we have the yellow block which is oscillating, that's why the rotation of the circle is got. So basically we can say that slider and a crank mechanism is a mechanism either to convert rotary motion to oscillating motion or oscillating motion to a rotary motion. And there are basically four parts of this particular mechanism. One is the crank. The particular bar which is being connected here, this is known as a crank, and this is the crank wheel. The other is a slider. The yellow block that you can see is a slider. The connecting rod, which is this brown one, and the guides, which are these blue ones. Now to understand this better, let's see a line diagram of this. Is it more clear? This particular thing that is rotating inside the circle, this is the crank, the rotating crank as it says. This is the connecting rod which connects this rotating crank to this particular slider, and this is the slider which is moving in these guides. So this circle is the crank is rotating and it's making this particular slider oscillate, or we can say that this slider is oscillating and it's making this particular crank or the crank wheel rotate, so that we have conversion of rotatory motion to oscillation or oscillations to rotation. Okay, now why do we want locus of this particular mechanism? We have the mechanism, then why do we want to plot the locus? So now we have different points on the bar or even outside that. So if we want to get work out of it, then what is it? So if I have my hand, this example I gave you last time also, I have my hand. Now if I want to know that how far this particular hand should go to reach this glass, then I should know the distance. Now when I move, I know okay, this is a particular path that my hand is moving or my palm is moving. then at all particular times I should know that what is the distance that I need to reach this particular glass. It's rotating like this, so I need to know at what particular time what is the distance from the glass. So that is the particular reason why we are going for locus of points. Now in a simple slider crank mechanism, the first problem that we are going to discuss, a simple slider crank mechanism that you saw in the figure, the line diagram, we are going to plot a locus of point which is there on the connecting rod. Now let us see the problem. In a simple slider crank mechanism, see, I want to say a very important point before we start solving problems. For any problem in engineering graphics or say any subject, it's very important to read each and every line of the question before even proceeding to write a single word in the answer sheet. So let's just concentrate on the problem first and not think of the solution. So let's look at the problem. In a simple slider crank mechanism, so now this point says that the mechanism that we have to visualize is a simple slider crank mechanism. So that line diagram, that oscillating slider and that rotating crank with a rod should come in your mind, because until and unless you are able to visualize a particular mechanism, you won't be able to make that mechanism on paper, and plotting the locus is secondary. First you have to make that mechanism, then you will be able to plot the locus of that mechanism. So let's see. The first line of the question says in a simple slider crank mechanism. So I know I have to draw a simple slider crank mechanism. Now the second line, the connecting rod is 750 mm long. So it has given me the dimension 750 mm for the connecting rod. So I'll note it down on paper on my answer sheet. Now moving ahead, the crank OA. So we know we have to label the crank which is there on the right hand side, that circle, OA, and its distance is its length is 150 mm long. Now the next line, crank OA rotates clockwise. Now it is very necessary to know this particular fact, that it is rotating clockwise or it is rotating anti-clockwise, because you will plot the points according to what it says in the question. Rather, the point should go clockwise or they should go anti-clockwise, because if you make a figure which is going clockwise and the question says anti-clockwise, then the locus of point would be reverse of what is expected from the question. So it is very necessary that you follow what is written in the question, either it is clockwise or it is anti-clockwise. If it is not mentioned in the question whether it is moving clockwise or anti-clockwise, then it is up to you to decide that what you want to plot. And if you plot clockwise or anti-clockwise, both the things are perfect. Now the next, crank OA rotates clockwise while the end B moves along a straight line. So another thing is clear, that B is the point B, the slider will be at point B because it is oscillating in a straight line. So from this particular sentence it is clear that a crank OA is rotating clockwise and B is moving along a straight line passing through O. Now another important point that has come up in this particular line, now we have seen the crank OA. O is the center of the crank from about which it is going to rotate, and we say कि B is moving along a straight line passing through O. This gives us a very specific indication that the slider and the crank are on the same line. The center of the slider, the center of the crank lie on the straight line. If they don't do, they can be classified as offset mechanism, that we will be discussing in the second problem. So this particular sentence that says B moves along a straight line passing through O, and we know the crank is OA, it gives us an indication that the slider and the crank are both having the same axis, or say the center line. Now this is the information that they have given. Now what do they expect us to do? Trace the locus of a point 300 mm from A along the rod for one revolution of OA. Now they have said कि 300 mm from A. So we know that the connecting rod will be BA, or say AB. So on AB, from A, it has to be at 300 mm always. So this is the point that we want to plot the locus. and this whole procedure has to be done for one single rotation of the crank. So now let's head for the solution. The first point, draw the reference line. Why we are drawing the reference line? Because without the reference line we won't know where the axis of rotation of crank OA will be, where the slider will be. So it is very necessary to first of all draw a straight reference line. Now the next step. Step 2. Take a point on the reference line and name it as O. Why O? Because my center of crank is O. So I will first make my crank. So I will name it as point O. Now with radius equal to the crank, that is OA is equal to 150 mm. On your compass, take the radius as 150 mm and draw a circle. This particular circle can be known as a crank circle or crank wheel or whatever you want to say. This is the guide, or this is the locus of points of OA where the crank is going to rotate. We have labeled it as 150 mm. Now the next step, take any radius. Now if from O I draw any radius, I will get at any time the position of my crank, that is OA. So this is my crank. So my first objective is done, that I want to have a crank. Now the next thing is to draw the connecting rod. Why the connecting rod and not the slider? See, from A, the slider is at a particular distance AB, or say the point B is at a particular distance from A. So first of all, from this particular position of A, we need to mark what will be the position of B. Here we go. So with A as center, what are we going to do to mark the position of B? With A as center, we will keep the pointed end of the compass at A, and with radius equal to 750 mm, that is my dimension of my connecting rod. So with that, I'll cut an arc at say point C, and this point C will be where my